Hi, I'm Cheryl Leach. In this problem, we're asked to use the general power rule to help us find the derivative of a function. But before we attempt that problem, let's take a minute and review just the power rule. For the power rule, let's look at y equals x cubed. To find the derivative, we bring down the exponent, copy over the expression that we're raising to the power, and subtract 1 from the exponent. So the derivative of x cubed is 3x squared. Right? That's an example of the power rule. Well, how is the general power rule different? In the general power rule, it's really just a special case of the chain rule. So the general power rule would be used to take the derivative of something like the quantity 2x minus 7 to the third power. Now, when I find derivatives, I always look for the main operation. I see several operations going on here. There's a constant multiple of 2, there's a subtraction problem, but there's also a cubing function. And the outside function, the one that encompasses the entire thing, is the cube. So that's the rule that I'm going to start with. Okay? And it's a power. So I'm going to be using the general power rule. So dy dx is going to be, I'm going to take that 3 and bring it down. 3. And then I copy over the thing that I'm raising to a power. This time it's more complicated. It's a 2x minus 7. And then I subtract 1 from the exponent. Okay? But I'm not done. Because this expression was more than just an x, I need to use the chain rule and multiply by the derivative of the inside piece. And the derivative of the inside piece is a 2. So my derivative is 6 times the quantity 2x minus 7 squared. Now, one thing that's kind of interesting to note about the power rule is that you could really use the chain rule to do my simple example as well. I start with x cubed. I bring down the 3, copy over the x, subtract 1 from the exponent. By the chain rule, take the derivative of the x, which is a 1. Because this is always an x, your derivative will always be 1, and it doesn't change the answer. When we have a composite function, this term is always more complicated, and so there's an extra piece when we do the chain rule. I hope that's helpful. Thanks.